Hi everyone, welcome to your Life 2 test review for Units 9 and 10. So let's first look at geometric sequences. The first section says, determine if the sequence is geometric. If it is, find the common ratio. So the first thing I do is I think figuring out what you multiply by first and then see if that pattern continues throughout the whole sequence. So to do this, the easiest thing is to do negative 24 divided by 4. Okay, and you get negative 6. So we multiply by negative 6. 4 times negative 6 is negative 24. And then what you can do, are you continuing to multiply by negative 6? Well, what is negative 24 times negative 6? Guess what? It's 144. Okay, and then we're going to multiply by negative 6 again. So times negative 6, and again you get negative 6 or 864. So is this geometric? Yes, because you multiply by the same thing each time, and your common ratio is negative 6. Okay, I want you to try number 2 now. So here's the answer. This was geometric, and your common ratio was negative 4. Okay, numbers 3 and 4. Determine if the sequence is geometric, then write the explicit and the recursive formula. So let's look at this. Are we multiplying by the same thing each time? Well, negative 6 divided by negative 3 is 2. So negative 3 times 2 is negative 6. Hey, negative 6 times 2 is also negative 12, and negative 12 times 2 is negative 24. So this is geometric. Okay, and so we need two things to write both of these formulas. I need my first term, which is negative 3, and I need my common ratio, which we just found, to be 2. Okay, we're first going to write the recursive formula. All right, the recursive formula. We have to state the first term first. So a sub 1 equals negative 3, because you have to have a starting point. And then a sub n equals a sub n minus 1 times 2. So that is the recursive formula. Then the explicit formula, we have a sub n equals a sub 1. Well, it's a sub 1 times r to the n minus 1. Now we can plug in a sub 1 is negative 3. Oops, I didn't want to put that in parentheses. Negative 3 times 2 to the n minus 1. Okay, I'm going to write your formulas real fast. Your recursive is a sub 1 equals blank. A sub n equals a sub n minus 1 times blank, which is your common ratio, right? And then your explicit is a sub n equals a sub 1 times r to the n minus 1. Okay, go ahead now and try number 4. Okay, here are the answers to number 4, your recursive formula and your explicit formula. Check your work, please. All right, numbers 5 and 6, you are given the explicit formula, and we want to find the term that is given. So here is the explicit formula, 4 times 2 to the n minus 1. We want to find the 12th term. So I'm going to plug in 12 where I see n. So I have 12 minus 1. That's 4 times 2 to the 11th, right? I go ahead and simplify the 12 minus 1, which is 11. So plug this into your calculator. 4 parentheses 2 in parentheses caret 11, and you get 8,192. That is the 12th term. Oops, there's the bell. All right, number 6, I want you to try now. You're finding the 11th term. Plug in 11 for n. Good luck. All right, here's the answer to number 6. Please check your work. We plugged in 11, so 11 minus 1 is 10. So then you plugged into the calculator, negative 3 to the 10th power. All right, number 7 and 8, given the first term and the common ratio, of this geometric sequence, find the term named in the problem. So we have our first term in a common ratio. I'm going to go ahead and write my explicit formula. That's the easiest way to find these term numbers that are so big. Okay, so we're given the things we need. We need our first term times our common ratio to the n minus 1. So I have a sub 12 equals negative 3 times negative 2 to the 12 minus 1. Negative 3 times negative 2 to the 11th. And then I just plug that in. Negative 3 parentheses, negative 2, caret 11. And I get positive 6,144 as my 12th term. All right, go ahead and try number 8 now. Check your answers to number 8. You plugged in 12 to find the 12th term, and you got negative 354,294. All right, then here we have numbers 9 and 10. You're given the recursive formula. Find the term and the explicit formula. Okay, so remember the recursive formula gives us exactly what we need. We're given the first term, and remember what you're multiplying by is at your common ratio. So we're going to write the explicit formula. It's just your first term times your common ratio to the n minus 1. And then finding term 11. 3 times 2 to the 11 minus 1, which is 3 times 2 to the 10. I'm going to plug that in my calculator, and I get 3,072. That is the 10th term of this geometric sequence. Okay, number 10. Again, oh, I want you to try number 10. Do that now. Okay, here's the answer to number 10. You should have gotten 10,000 or 1,024 or 1,024. Pause it if you need to check your work. All right, now we're going to look at our compound interest formula. A equals P times 1 plus R over N to the NT. I know it's crazy, but remember, as long as we can pick out our pieces, we're good. So Eddie is trying to earn some money for retirement. One of his friends suggests he invest $20,000 into an account which earns 12% interest compounded quarterly. How much money will Eddie have in his account after 30 years? So we need to know our different things. We need our P, which is our principal, which is our initial value. Okay, we invested initially $20,000. Our R is our interest rate. It says 12%. So 12%, remember, is 0.12. Then we have, let's see, we need our N, which is the number of times compounded a year. So look at the word after compounded. It says quarterly. How many times is quarterly a year? It is 4 times, okay? Just like there are 4 quarters in a year. We also need T, time is 30 years. So once we have these, we can plug all of this in. So we have A equals our initial value times 1 plus 0.12 over N, which is 4, to the 4 times 30. Now remember, before I plug this into my calculator, I do 4 times 30 so I don't mess up. So 1 plus 0.12 divided by 4 to the 120. Now make sure you're plugging this in the calculator with me so you know that you know how to do this. So 20,000 parentheses 1 plus 0.12 divided by 4 into parentheses caret 120. So this gives us 694,219.74. So in 74 cents. It's a lot of money, right? Okay, so that's how much is left in Eddie's account after 30 years. Okay, now part B says find the amount of compound interest at the end of these 30 years. So I'm taking how much is in the account, okay, which is this amount, okay, and I'm going to subtract what I've originally started with. Okay, so I'm going to subtract what I originally started with, and I want to see how much money did this grow since I put in my money. So it looks like $674,219.74. That is the money that I got that I did not actually spend any money on, right? Cool. So go ahead. I want you to try number 12 now. Good luck. Okay, check your answer for part A, please. Check your answer for part A. Make sure you did this right, so to do part B, you'll also get that right. Right now, I want you to do part B, please. Okay, here is the answer to part B. $23,509.45 is the amount of compound interest that Lucy has gotten since she invested her $7,500 in her certificate of deposit. All right, just a few more here. Number 13, we're given three different functions here. We're given f of x, we're given g of x, and we're given h of x. So we're going to compare all of these things. All right? So the first part says order the functions above in descending order according to their corresponding y-intercepts. Okay? Remember, the y-intercept is when you plug in 0 for x. So you can plug it into an equation here. You can look at it for a table, and you can look at it in a graph. Before I even do this, I want you to try these right now. So everyone, right now, I want you to try I don't even want you to fill this in. I just want you to find the y-intercept for f of x, g of x, and h of x. Okay, do that now. Here are your y-intercepts, 0, -4, 0, 30, and 0, -3. Now we're going to order them in descending order, which means the biggest to the smallest, okay? So right now, I want you're going to either put like f of x, g of x, or h of x. Go ahead and put these in order. This is the biggest y-intercept to the smallest y-intercept. So you're just putting, these are the three options. You're going to put in g of x, f of x, g of x, and h of x. You're going to put them in order from greatest to least. Okay, try that now. Okay, here is the order. G of x was the biggest because it was at 0, 30. That's way up there on the y-axis, right? Then h of x, and then f of x. Okay, if you're looking at this, here is h of x, y-intercept. This is where f of x is. Isn't h of x higher than f of x? Yes. Okay, so now we're going to look at the average rates of change of these. Okay, I'm going to erase this work I've done because I need a little more room. Okay, so we're going to look for the average rates of change over the interval -2 to 0, -2 to 0. So, also, one thing I didn't point out, can you tell me on number 13, is this linear or exponential? F of x. It's exponential, right? Because it has an exponent. Okay, what about g of x? Hey, we're positive, 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 negative, negative, negative. I know that can't be exponential. So it looks like I'm subtracting 35, and then I'm subtracting 35, and then I'm subtracting. So that is linear, isn't it? Okay, so I know this is linear. And then obviously h of x, it curves, and so this is exponential. Okay, that's just something I wanted to point out. So here, when we're looking at the average rate of change over the interval -2 to 0, for an equation, you have to plug in -2 for x and then plug in 0 for x. So we have f of -2 equals -4 times 1/2 to the -2. Oops, not 4, -2. Okay, plug that in your calculator. -4 times 1/2 to the -2nd, and you get -16. So I plugged in -2 for x, I got -16 for y. And now, oh man, I already erased it. When we plugged in 0 for x, what did I get? Negative 4, right? So 0 comma negative 4. I can use these as 2 points, x1, y1, x2, y2, and let's find the rate of change. Negative 4 minus negative 16 is plus 16 over 0 minus negative 2, that's plus 2. So that's 12 over 2, which is 6. So I know the rate of change for f of x is 6, okay? So then we come over to the table, okay? We come over to the table. We're looking at the interval between negative 2 and 0, so I'm going to use those two x values. So I have the point negative 2, 100, and 0 comma 30. And we're going to do the rate of change again, right? 30 minus 100 over 0 minus negative 2 is plus 2. That's negative 70 over 2, which is negative 35. And I have a question. Do we know that? Didn't we say earlier that we were subtracting 35 each time and that this was a linear? Yes, we did. So with linear, it didn't really matter where we found the rate of change because it has a constant rate of change. Okay, so I know the rate of change for g of x is negative 35. And then I'm going to come over here to h of x, and I'm going from negative 2 to 0. So I'm looking here. We already have our point right here. Negative 2 comma 0 is an actual point here. And then I'm looking down to this point, 0 comma 1 to negative 3. And with this, you can find the 2 points and do the slope formula, or I can just do rise over run. I went down 3 over 2. So the rate of change for h of x is negative 3 over 2, which if you want to write that as a fraction, is negative 1.5. Okay, so I just kind of did those with you, but I want you right now to fill in the rate of change, put them in order from greatest to biggest to smallest, okay? So do that now. All right, check your answers. G of x, even though g of x had a negative rate of change, it was decreasing at a faster rate than f of x or h of x, okay? F of x then had the next one, and then h of x has the smallest rate of change. Okay, it wasn't changing as fast as the other ones. All right, now I'm going to do one of these, and you're going to do the next two. Hannah buys 6 shirts and gets a 10% discount. I just want you to tell me if this is linear or exponential. So she buys 6 shirts, 10% discount. Okay, this is a percent, but how many times is she getting this discount? She's only getting this discount once, right? So it's a percent, but she's only getting it once. That means this is linear, okay? So remember your keywords for exponential. You're looking for words like double, triple, half. That really gives it away that it's exponential. You're also looking for percents, but that are percents every year. So increasing by 10% every year, or decreasing by 3.8% every day. So those are some examples of exponential. All right, so go ahead and do numbers 15 and 16 now. Okay, you should have gotten exponential for both of them. The keyword for number 15 was doubles, and number 16 did have a percent, but the mosquitoes were increasing 12% each day. That means it increased by 12%, and the next day it increased by 12% again. All right, so this is just a little review. Remember to continue looking at comparisons between linear and exponential, okay, and just some other things on it. So good luck on your test. Hopefully this helped you.